Okay, so today we have sequences. Let's take a look at them. First of all, what are the meaning of sequences? What's the meaning of a sequence? A sequence is a collection of items that are arranged in a specific order. A collection of items that are arranged in a specific order. Things that are well arranged is a sequence in a specific order, either in an increasing order or in a decreasing order, where each term is obtained according to a specific rule, according to a rule. Okay? When each term is arranged according to a specific rule. Or we can look at sequence as an order set of numbers. You can call sequence an order set of numbers. Each number in the sequence is called a term. Each number in the sequence is called what? A term. Every number in the sequence is called a term. It's just an order set of numbers, and each number in the sequence is called a term, and the location of a term within a sequence is called its position. If, for example, if this is the first one, if the first term, if this is the first number, this will be the first term, and then this will be the second term. The 6 will be the third term, and 7 will be the fourth term, and 8 will be the fifth term. Now, their location is their position. If you are in the first place, then you'll be in position 1. If you're in the second place, you'll be in position 2. If you're in the third place, you'll be in position 3. If you're in the fourth place, you'll be in position 4, and so on and so forth. So we can actually make, if you give a sequence, you can make a position out of it. If you're giving, you can draw a table between term and position and actually do that. Okay, so I can draw a table to show, let's say here's my position. Okay, here's for my position. Here's for my position. And here's my term. So I can write this 1, 2, 3, 4, 5, for example. So this is my position 1. Let's change the color. Let's change the color to maybe black. Here's my position 1, position 2, position 3, position 4, and position 5. I can even include the nth term. I include the color called the nth term. The nth term, the last term also of the sequence. Okay, now the term, the first was 4, right? The first number was 4. We can use a different color actually. The first number on the term is 4. The second number was 5, right? And there's 6, and there's 7. These are the terms, and there's 8. So 4 is the first term. 4 is the first term, okay? 4 is the first term. This is the second term. This is the third term. This is the fourth term. So in order to find what type of sequence, we have to find what we call the term-to-term rule. In order to find what type of sequence, we have to find what the term-to-term rule. You can see this one is just greater than this with 1. So 5 minus 4 is 1. So the difference between this and this is plus 1. Just add 1 to this, you get this. So we say this is plus 1, the common difference, or what you call the term-to-term rule. And then the difference between this and this is also plus 1, right? So you can see this is an arithmetic sequence. The difference between this and this is plus 1. Okay, the difference between this and this is plus 1. So they have a term-to-term rule or a common difference. The difference between this and this is plus 1. They have a term-to-term rule or what you call a common difference, right? They have what we call a common difference. All of them, they have just plus 1 plus 1. So this is a linear sequence called the arithmetic sequence. So you can simply say this is an arithmetic, because we have types of sequence. I'm going to mention them now. Types of sequence: arithmetic sequence, This one is an arithmetic sequence. So when the difference is plus or minus of same number, then we call it arithmetic sequence. Arithmetic. So when we talk about types of sequence, number one is arithmetic sequence. Okay. Other types of sequence. Number one is arithmetic sequence. Okay. Arithmetic sequence are those sequences that have plus or minus between them. Okay. Plus or minus of same number. The difference between them, the term to term rule, is either plus 1, plus 2, or plus 3, and it's same. Plus 2, plus 2, plus 2, plus 2, plus 3, plus 3, plus 3, or minus 3, minus 3, minus 3, minus 3 is same. So this type of sequence, if it's increasing, it will be plus, positive number, plus 2 or plus 5. If it's plus 5, you say 4 plus 5 will be 9. If it's 9 plus 5 will be 40. 40 plus 5 will be 90. 90 plus 5 will be 24. So the number would have be like that. 4, 9, 14, 90, 24. That would have been the sequence if the difference was plus 5. Then if it's a negative, it means it's decreasing. The sequence is decreasing. Maybe 30 minus 3, 27. The next one is 27. The next one, 27 minus 3 will be 24. 24 minus 3 will be 21. 21 minus 3 will be 18. So it would have been like that: 30, 27, 24, 21, 18, like that. That would have been the sequence. So this type of sequence, that increasing or decreasing, the term to term rule is positive or negative with same number, then you say it's an arithmetic sequence. This is called the term to term rule. Term to term. Or in another way, we can just call them the common difference. We can just say common difference. Okay? We can say term to term rule, or we can call it common difference. We say this sequence has a common difference. So when a term has a common difference, or we say it's an arithmetic sequence. When when there is a common difference, either positive common difference or negative, we say it's an arithmetic sequence. Is that okay? Either positive common difference or a negative common difference, we say it is an arithmetic sequence. Now let's take another type of sequence that we may look at. It's another type of sequence is called the quadratic sequence. We have what we call the quadratic sequence. Okay, quadratic sequence. This is quadratic. This is when the sequence, the first difference is not common to all. After you find the difference between the second term and the first term, and the difference between the third term and second term, and the difference between the fourth term and third term, and the difference between the fifth and fourth terms, the difference is not same. The difference is not same number. And it is after you've done it for second level, then you find same difference. That type of sequence, we're going to do an example to illustrate those ones. That type of second level difference that will be uniquely same is called a quadratic difference. It's called a quadratic sequence. Then the third one is called cubic sequence. Cubic sequence. Cubic sequence is a type of sequence where the first level, there's no common difference, and the second level, second difference, there's no common difference. It's only the third level difference that you have a common difference. In the third level, you have a common difference. That type of sequence is called a cubic sequence. We're going to do each and every one of these in order for us to understand completely what we're saying. Then we have the fourth type of sequence, which is called the exponential or the geometric sequence. Exponential or the geometric sequence. Okay, the fourth type of sequence is the exponential or the geometric sequence. Okay, exponential or the geometric sequence. This type of sequence, they don't have, the term to term rule is a ratio. The term to term rule is a ratio, it's a common ratio. What do we mean by common ratio? It's either the difference is coming from the geometric. Okay, the difference is coming from, just a moment, okay? Let's write the name here, sequence. All of them, they are sequences, so I put them together, geometric sequences. Okay, these are the type of sequences that we will look at, in this chapter, we look at the arithmetic sequence, we look at quadratic sequence, we look at cubic sequence, we look at exponential or geometric sequence. Now, I was explaining the exponential sequence, geometric sequence. This type of sequence, they don't have a common difference, but they have a common ratio. They have a common ratio, meaning you have to divide the second one by the first one, or you divide the third one by the second one, or you divide the fourth one by the fifth one. You have a common difference. That type of sequence is an exponential or a geometric sequence. Okay, so now let's go back to this. Let's see which method they treat the arithmetic sequence. Now, say the subscript notations is used to talk about a particular term. A1 it would be the first term in a sequence. A7 will be the seventh term. So for this course or for this text, we'll be using A1 for the arithmetic for the first term in the sequence, A2 for second term, A3 for third term, A4 for fourth term, A6 for sixth term, A7 for seventh term, and AN for the nth term. AN for the nth term. So the nth term is AN. The nth term is AN. Okay? So that's for this sequence. So if you take a look at this, these are the positions which we've shown in the table. Position 1, position 2, position 3, position 4, position 5. And these are the positions. And then you have the nth term. Okay? The nth term. The first term is A4. Second term is 5. Third term is 6. The fourth term is, which is A4. Fourth term is 7. And the fifth term, which is A5, is 8 in this regard. So AN will be the nth term. AN will be in this regard, okay? AN will be the nth term. Okay? AN will be the nth term. Now let's go to what is the position to term rule. What's the position to term rule? Let's take a look at position related to term. What's the rule between the positions and the terms? What's the rule connecting position and term? So we call it position to term rules. This rule gives the nth term of the sequence in terms of n. It gives the n terms of a sequence in terms of n. Now, this is a very powerful piece of mathematics. Let's take a look at it. With a position to term rule, the 100th term of a sequence can be found without having to know or work out all the first 99 terms. You don't have to work out once you know the rule, the formula for the nth term, then you can use it to calculate the 100th term. So you just substitute 100 in place of that term. Okay? So you don't have to calculate. It's a powerful rule. You don't have to calculate first term, second term, third term, fifth term, sixth term, seventh term, eighth term, ninth term, 10th term, 11th term, 20, you get up to 20 term, 30 term, 40, 50, 60, 70, 80, 90, 99, then before you can do the 100th term. No. So once you know the nth term formula, you can calculate the 100th term as quickly as possible, because there's what we call the position to term rule. And what that says is that the link between the link within this n in position location and the an in the term location is that an is always 3 more than n. Look at it. The an is always 3 more than n. Look at it. Here is 4, here is 1. This is 3 more than this, because 1 plus 3 will give you what? Will give you 4. 2 plus 3 will give you 5. You look at every question and see. It's called position to term rule. 4 plus 3 will give you, so it's always n plus 3. So the an formula is this n plus 3, n plus 3. So the position to term rule is an is equal to n plus 3. Now, let's go back to the board. The position to term rule for arithmetic sequence. Now we're treating the first one, which is the arithmetic sequence. Let's take a color we might like. Arithmetic sequence. Okay? So in arithmetic sequence, we are talking about the position to term rule. We're talking about the position to term rule. The position Position to term rule. We're talking about the position to term rule. Now let's take a look at this our sequence. You can see position and term. Okay, let us say this is n and this is an. Okay, so an is n plus 3. Because if you add 3 to this, if you say 1 plus 3, you get 4. You get 4. So what connects this to this is this position plus 3. You get 4, right? Then this 1 plus 3, this 2 plus 3, you get 5. This 3 plus 3, you get 6. This 4 plus 3, you get 7. This 5 plus 3, you get 8. So when you add 3 to the position, you get the terms. So which means this formula will be an, this formula, position to term rule, an, will be equal to n, whatever is in the position. N is the symbol for position, plus 3. N plus 3. You just add 3 to n. Okay? So if I want to find a1, remember, this is for term. This is symbol used for term. So if I want to find the first term, I will say a1, okay, it's first term, is equal to position 1, which is 1, position 1 is 1, plus 3, and that will give me 4. That will give us 4. Plus 3, that will give us 4. And 4 is the number, is the first term, right? If you look at this table, 4 is the first term. Okay? 4 is the first term. So an is equal to n, this one, n, which represents position, n plus 3. Okay, n plus 3. So if you are looking at the first position, you say 1 plus 3. If you are looking at the second position, you say 2 plus 3. If you are looking at third position, you say 3 plus 3. If you are looking at fourth position, you say 4 plus 3. If you are looking at fifth position, you say 5 plus 3. So that's how we get. So we can use this formula to calculate all the, if you want A2, that's the second term. Second term will be what? You say position 2 plus 3. Position 2 plus 3. That gives you 5. And that's actually the second term, right? So since this sequence is working for us, if you want let's jump now to the fifth term. If you want the fifth term, this will be what? You say 5 plus 3. Okay? 5 plus 3. 5 plus 3, that will give us 8. That will give us 8, right? If you want the seventh term, if you want the seventh term, if you want the 10th term, let's say 10. The 10th term, this will be what? 10 plus 3. Am I right? Position 10 plus 3. Right? That will be 13. Now, let's say if I want the 100th term, let's jump now. 100, the 100th term. What will it be? So you can find any number of any term. You say 100 will be 100 plus 3. Am I right? 100 plus 3, because it's position 100, right? 100 plus 3. That will be 103. That will be 103. That's the value of the term you will find there, right? Okay, so this is a position. This is called position to term rule. This is position to term rule. Use the position to term rule to find your sequence. Position to term rule to find your sequence. To find your n term, the number of term in a sequence. Now let's go to this. So the position to term rule is this, which we have itemized for this question. In another question, it may be an equals to n plus 4 or n minus 2, n wherever. It depends on how this relate to this, this relate to this, this relate to this. We'll see in another example, the formula will be different. In another example, the formula might be different. Now, what is term to term rule? Now, let's talk about the term to term rule. We've talked about position to term rule. Now, let's talk about the term to term rule. Let's talk about the term to term Let's talk about the term to term rule. Okay, you say term to term rule gives the n plus 1 terms, n plus 1 term in terms of the n term, right? So you say this one is an plus 1 is given in terms of an now. The term to term rule, if the term is known, then the next one can be worked out. If the term is known, the next one. Now let's take a look at the link, the defining link between the term to term rule. So you say the link between, look at this n term, this for position, this n for position, this an for term, right? Now the link between the an and the next one is an plus 1. If you want to find the next one, you already got this one. So you go to add 1 because the common difference is 1. Okay? This link is not between position and the n term. This link or this formula is not between position and the n term. This formula is for between this term and the next one and the next one and the next one and the next one. So this one is an plus 1, meaning you want to find the next one. An plus 1 is equal to whatever an you have here plus whatever is the common difference, or what is the term to term rule, whatever is the term to term rule. So this one will be the term to term rule formula. Let's go to our board. The term to term rule formula will be not position to term now. So term to term rule will be term to term. Term to term rule will be, you're looking for, you already have your n term, the term to be an. If you're looking for the next one, you say an plus 1. If you're looking for the next one. Because why do we say plus 1? It's not like every time it's plus 1. For this question, because the common difference was 1. The difference between, look at it, the difference between this first term and the next one is 1. That's this minus second minus first term, you get plus 1. This third term minus the second term, you get plus 1. This minus this, you get plus 1. So there's a common difference, a term to term rule of plus 1. So that's why if you want to find the next term, if you are here, you just say plus 1, you get, the next term will be 9. The ninth term will be 9, right? The sixth term will be 9 here. The next one again will be 9 plus 1, which is 10. The next one will be, so that's why the formula is, if you want to find the next term, an plus 1, which is the next term. An is the number of terms. Plus 1 means the next one. If you want the next one, you say whatever is the an, the previous one, which is this one. If I want the next one now, the previous one is 8. So I'll just say plus 1. I'll say an plus 1. So means 8 plus 1, I'll get the next one. For example, if you are in the third term, you just say the previous one is 6. 6 plus 1, you get 7. That's how we got 7. So it's like you are just adding 1 if you want to. So we write it here. We write it out. The term to term rule for an, you say an plus 1 is equal to an plus 1. Because not every question has this same formula. So different question you see, because for the common difference for the next question may be plus 3. If it's plus 3, then you say an plus 3. You say an plus 3. But for this question, it's plus 1. So to find the next term, you keep adding 1. So if I want the seventh, just now we said the sixth term. Just now we said the sixth term. The sixth term, if you are doing the sixth term, you will get what? 9. Meaning there's a difference of 3 because you just say 8 plus 1. 8 plus 1, you get 9. Right? So that's how it goes. That's how for the term to term. Are you with me?
Yeah.
Do you understand?
Yes.
Do you understand? Okay. So that's the rule connected the term to term rule, okay? How do I understand the position to term and the term to term rule? how to understand the position to term and the term to term rule. These can be used to generate a sequence. Okay, you can use this to generate a sequence. From a given sequence, the rules can be deduced. Once you're given a sequence, you can look at the rules that connects one term to the next term, right? Now, when you recognize this and you being aware of the types of sequence, then it will help you. You have to know it's a linear sequence. Linear sequence and quadratic sequences. We have geometric sequences. We have Fibonacci sequences and other sequences. Okay, the one that concerns us for Cambridge IGCSE, you need to know the linear sequence, which is arithmetic sequence. You need to know the quadratic sequence. You need to know the cubic sequence. You need to know the geometric sequence, and so on and so forth. Is that okay? So, example, position to term rule for this sequence. Now, let's take a look at a given sequence. Okay, this sequence was not given, but the formula was given. This is the position to term rule. So, for position 1, you know position 1, n will be 1. So, what will be the term? So, you say A1 will be 2 times 1. 2 times 1 is 2. Then 2 minus 3 will give you negative 1. So the first term will be negative 1. So let's say you're given this formula. Let's go to the whiteboard. Let's find the sequence. You're given this formula. Another question. Let's say this question 2. Okay, let's change. This is a different question. Let's change our color. Okay, let's change our color completely. Okay, so this is, let's say this is question 2. You're given a formula an, position to term rule. Position to term an is equal to 2n minus what? The formula was what? 2n minus 3, right? Now they want you to find the term. They've given you the formula, the position to term rule. They want you to generate the sequence. They want you to generate the sequence. So remember, n is for position. N is for position. An is for term. So if I want A1, using this formula, if I want A1, if I want the first term, the number that will be in my first term, then you see I've replaced n with 1. So I will also use n here to be 1. So I'll say 2 times 1, or 2 bracket 1, as the case, whatever, how you want to do it. 2 times 1 or 2 bracket 1, same thing, then minus 3. That will give me what? 2 times 1 is 2, 2 minus 3 is negative 1. So I'll get negative 1, right? Right? That's my first term. So if I want my second term, A2, I'll get 2 bracket 2, or 2 times 2. Are you with me? 2 times 2 minus 3. Then I will get what? I'll get 4 minus 3. 2 times 2 is 4. 4 minus 3, that's 1. I'll get positive 1. Then if I want A3, the third term, okay, A3 is the third term. If I want the third term, I will say 2, this 2 is constant from this formula. 2 times, but this will be changing. Position 3 now. If you are in position 3, you multiply by 3. Okay, 2 times 3, that's 6. 6 minus 3, I'll get 3. So my third term will be 3. Okay? Then my fourth term, see, I'm generating a sequence now, which I'm going to write out. My fourth term will be what? 2 times 4. 2 multiplied by 4 minus 3. Okay? So this will be 2 multiplied by 4, you get 8. 8 minus 3, you get 5. Okay, let's do one more. A5, the fifth term of the sequence, will be 2 multiplied by 5. 2 multiplied by 5 minus 3, right? 2 multiplied by 5 minus 3. This will give you, 2 multiplied by 5 is 10. 10 minus 3 will give you 7. So we've generated the sequence. Now we write out the sequence. Horizontally, we can bring out our sequence, right? The first one was negative 1, right? Negative 1, there, comma. What's the second number? 1. What's the third number? What's the third number? 3. 3. Third number was 3. What's the fourth number? 5. What's the fifth number? What's the fifth number? 7. Okay? You see, I can put dot, dot, dot. So it continues. Yeah, you can keep doing it. What if I ask you to find the 100th term? You see this. The 100th term, okay? The 100th term will be A, you remember the formula, AN is equal to 2n minus what? 2n minus what? 3, right? That's the formula. So the 100th term will be A100 for this position to term rule. A100 will be equal to 2 times 100, right? 2 multiplied by position 100, that will be 200 minus 3. 200 minus 3 will be what? Will be what? 197, right? 200 minus 3 is 197. So the 100th term will be 197. So you can use it to find any position. The 100th term will be 197. Okay? So that's that for this formula. Use this formula to find generate the sequence. Is that okay? Now let's go back to, so you can see minus 1, 1, 3, 5, and 7. So the first 5 terms of the sequence from this position to term formula gives you this sequence. Minus 1, 1, 3, 5, and 7. Is that okay? Now the big question says write down the term to term rule for the sequence. For the same sequence, right? Now let's write down the term to term rule for the sequence. Okay, first of all, to do that, we have to find the common difference or the term to term rule. Now let's go to our whiteboard. And then we have to write the formula at the end of the day. We have to write the formula. But before we do the formula, remember our sequence. Our sequence is what? Let's rewrite it out. Because we need it. Negative 1, 1, 3, 5, and 7, right? So we have the B part of the question. We need to write the term to term rule. Right there. Right? The formula for the term to term rule. Right? The formula. Write the formula for the term to term rule. Term to term write the formula for the term to term rule. Okay, so to do that, first let's write the sequence out. Negative 1, comma, 1, comma, 3, comma, 5, comma, 5, there, comma, there's 7, right? Let's stop here first. So you see the difference. Let's change the color. Let's change the color. See the difference between this, the first term, and the second term. The difference is from minus 1 to 0 is 1, from 0 to 1 is 2. So here is positive 2. Here is positive 2. Then from 1 to 3 is also positive 2, right? The difference is positive 2. That's 3 minus 1, you get 2. From 3 also to move to 5 is the difference is positive 2, right? The term to term rule is positive 2. From here to here also, from 5 to 7, the difference is positive 2. So it has a common difference. Once it has a common difference, if the difference is same, then the problem is easy. So you just say an plus 1, if you find it the term to term rule. That means to get the next term, you will say this will be equal to what? An, whatever you get as an, right? Whatever is the term, Maybe if it's first term, it become A1 plus the common difference, plus 2, plus 2. Okay, so this is how we generate the formula for the term to term rule. This is how we generate the formula for the term to term rule. Is that okay? So you just say it's whatever the term is, an. Okay, the sequence is the term. The first term, second term, third term, fourth term, fifth term. Okay, the sequence gives the terms. From the sequence we get the term 1, term 2, term. So if it's first term, you say first term plus 2. Minus 1 plus 2, you get 1. You know, right? If you're considering this first one, if you want to get this one, you say the first term plus 1, meaning I'm taking a step further. That's the meaning of plus 1 here. You say I'm going to the next one. An plus 1, that's this one plus 1. If I add 1, in terms of position, you know, this position 1, this position 2, this position 3, this position 4, and this is position, okay, this position 4, and this is position 5, okay, in terms of position, which this position represents n, and this one represents an, term represents an. So to get the next one, you say an plus 1. So an plus 1, meaning if I'm in the first term, I want to get the second term, I'll say an plus 1. An plus 1 will be saying whatever an value is, you add 2 to it. You add 2 to it. That's when you can get to the second term. When you add 2 to the first term, okay, an is the first term now, a1, which is a1, if you are considering first term. But an represents any of the term you are considering. So this is used for any of the term. The an is used for this to represent term. An is used to represent term. So if you are considering a1, you're going to say minus 1 plus 2. That's how this formula is generated. If you are considering this one, you want to get the third term. You want to get the third term, you say the second term, which is 1 plus 2. 1 plus 2, you get the third one. If you want to get the next one, after you got it, the third one, it will be third plus 1, right? To get the fourth one is like a3 plus 1, right? So to get the fourth one, it will be a3 plus 2. See, a3 is what? This a1, a2, a3. a3 plus 2, that's 3 plus 2, you get 5, you get a4. To get the next one, you say a4 plus 1, which will be a5, will be a4, whatever the answer for a4 was, which is 5, plus 2, you get the a5, which is the next one. So that's how this term-to-term position formula is given. Is that okay? That's how that position formula is given. Now let's move on quickly. So here is a work example. Let's take a look at this. Find the first 5 terms of the following sequence. Find the first 5 terms of the following sequence. The n term equals to 20 minus 2n. Then another one, the n term is equals to 20n squared minus 3. The n term is 1 over 2n. So that's the first one. That's A. Then the B, find the second, third, fourth terms in each of this sequence. So look at this sequence. They ask you to find the second one, the third one, and the fourth one. Okay? With A1, here they define A1. A1 is equal to 3. For this one, A1 is 2. So if A1 is 3, so you say 3 plus 1. If this is A1, then 3 plus 6, you get the next one. Now let's first of all take a look at the first one before we take a look at the second one. Look at the first one. We say find the first 5 terms of the following sequence. Find the first 5 terms of the following sequence. Now, the n term is equal to 20 minus 2n. Now, let's take a look at that. This is a position to term rule, right? So we say the n term means we have the position to term rule, you see. Once they give you the n term, it means we have position to term rule. We have position to term rule. So you can write n, which represents position. You write 1, 2, 3, 4, 5 because they want the first 5 term. Then the term, an. So how do we generate it? So you go to this formula. Remember position to term rule, right? So it says the calculations are usually easy, so you can do them mentally even without using a calculator. So now let's say the formula has been given. It says 20 minus 2n. So for the first case, n is 1. So 2 times 1, you get 2. So 20 minus 2. Let's write the formula in our board. 20 minus 2n, and n is 1 for the first case. So let's generate the first 5 terms quickly. Okay, let's generate for this question. So for this question, we take a different color because it's a complete different question. Which color should we use?
Green.
Eh?
Green.
Green. This one? Okay. So for this question number 3, let's call this question number 3. So for this question, the formula is to find the first 5 terms in a sequence, 20 minus 2n, right? I think this was the formula of the n term. And you know, once they tell you about n term, once they say n term, they're talking about position to term rule. They're talking about position to term rule. So we can generate this sequence as fast as we can. So for the first term, we're going to generate the first 5 rules. So for the first one, n will be 1. For the second one, n will be 2. N equal to, so you can define your n to be 1, 2, 3. You know, these are the position, right? Position we say is for n, 5. So these are n is 1, 2, 3, 4, 5. So when n is 1, let's get the first sequence. So you say 20 minus 2 times 1, 2 brackets 1. 2 times 1 is 2. So 20 minus 2 is 18. So we will get 18 as our first sequence, right? Our first term in the sequence. Then for the second case, we say 20 minus 2 times 2. For the second position 2, n is 2. 2 times 2 is 4. 20 minus 4 is 16. So we will get 16 as our next term in the sequence. And then for the third one, it will be 20 minus 2 times 3, because we're in position 3 now. N is 3. 2 times 3 is 6. 20 minus 6 is 14. So we will get 40 as next number in the sequence. So for the fourth case, or for the fourth term, you say 20 minus 2 times 4. 20 minus 2 times 4. So we get 20 minus 2 times 4. We get 2 times 4 is 8. 20 minus 8 is 12. So you get 12 here. For the fifth one, it's 20 minus 2 times 5, because this is n is 5. For position 5, n is 5 for the n term, for the fifth term. So we say 2 times 5 is 10. 20 minus 10 is 10. So this is our sequence. Now let's write them out in order. Let's write the sequence out. So these are first 5 terms in a sequence. 18, 16, 14, 12, 10. Okay, these are our first 5 terms in a sequence. If you want to find the common difference now, you will see, you agree with me that the common difference, okay, let me use black for this one. You agree with me that the common difference will be minus 2. Why? Because we always get the term to term rule by saying second term minus first term. 16 minus 18 is negative 2. Okay? 16 minus, we always say second term minus first term, not first term minus second term. Is second minus first, is third minus second, is fourth minus third, and is fifth minus fourth. So for this one, if you want to find the term to term rule, you say 14 minus 16, you get negative 2. For this one, you're going to say 12 minus 14, you get negative 2. So it's a common difference of negative 2. So for this one, you're going to say 10 minus negative 12, you're going to get negative 2. So you're going to have, so we can get even the formula for the 10 to 10 rule. You can get a formula for the 10 to 10 rule. So for the 10 to 10 rule, the formula will be an plus 1 will be equal to an minus 2, because the common difference is negative 2, an minus 2. This will be the formula for the 10 to 10 rule. This will be the formula for the 10 to 10 rule. An, whatever an is, minus 2. 18 minus 2, you get 16. 16 minus 2, you get 40. So you always subtract 2 from the previous term. You get the following term for this particular sequence. So I think we generated the sequence. That's what they asked us. They say generate the first 5 sequence. That's what they've asked us. I have also given you the formula for the 10 to 10 rule. We've also given you the formula for the 10 to 10 rule. Okay, now let's move on. I think we've done for this first one. We've taken that for this first one. And then let's take a look at this formula, 2n squared. Okay, 2n squared minus 3. 2n squared minus 3. So look at the first one, we've done that. Let's see the other one, 2n squared minus 3. What you just need to do is to be, in place of n, be putting the numbers, right? Be putting 1, 2, 3, 4, 5, 6, and so on and so forth. So let's write that one out and see how we can do that quickly. Roman figure 2, question A, Roman figure 2 is the nth term is equal to 2n squared minus 3. Am I right? Was it the formula they gave? 2n squared minus 3, 2n squared, let's see. 2n squared minus 3, yeah. So the position to term rule, once they say n term, they're talking about position to term rule. So to get the first term, so I'll just generate the first term. So it will be 1 square. 1 square is 1, because n will be 1 for the first term. N will be 1. So 1 square is 1. 1 times 2 is 2. 2 minus 3. 2 minus 3 will be what? That's negative 1, right? 2 minus 3, negative 1. So the first one we get negative 1. The second one, 2 square, n will be 2 now. 2 square will be 4. 4 times 2, 4 times 2, we get 8, right? 8 minus 3, 8 minus 3, we get 5, right? The second number in the sequence will be 5. Now the third one, n will be 3. So we say 3 square. 3 square is 9. 9 times 2, 3 square is 9. 9 times 2, you get 80. 80 minus 3, 80 minus 3, you get 15, right? 80 minus 3, you get 15. So this is the next number, next term in the sequence. The next one is n is 4, right? 4 square. 4 square is 16, right? 16 times 2, you get 32. 32 minus 3, 32 minus 3, you get 29, right? You get 29. Then the fifth one, n is 5. 5 square, you get 25. 25 times 2, you get 50. You get 50. 50 minus 3, 50 minus 3, you get 47, right? 47. Remember this 29. So the sequence is let's write out the sequence. Negative 1, negative 1, comma, we have 5, comma, we have 15, comma, we have 29, and we have 47. So this is they asked us to find the first 5 terms. 1, 2, 3, 4, 5. We've generated the first 5 terms of the sequence. So let's not waste time. I think we've got the first 5 terms of the sequence. Look at the number, negative 1, 5, 50, 29, 47. This is the first 5 terms of this sequence using the formula they've given us. Now the last one for Roman figure 3. Okay, we almost stop here. Last one for Roman figure 3 is there's the question again. I've passed. Okay, I've seen the questions. The last one is 1 over 2n. The n term is 1 over 2n. So we go to the board. Okay, before then, 1 over 2n, you'll be replacing n with 1, 2, 3, 4, like that. So the n term for Roman figure 3, A Roman figure 3 question, A Roman figure 3, A Roman figure 3 question, the n term is equal to what? The n term is equal to 1 over 2n, right? 1 over 2n. So the first term, this is the formula. So this position to term rule. So to get the first sequence, the first term in a sequence, you say 1 all over 2 times 1. Because n will be 1 for the first position. N is for position 1. For position 1, n will be 1. So 2 times 1, that's 2. So 1 all over 2. So the first term in the sequence will be 1 all over 2. If you want to write in decimal, you can write 1 over 2 is 0.5. Or you leave them in fraction like this. We write the sequence in fraction. The sequence can be in fraction, no problem. Then for the second one, for your A1, right? If we are defining them term by term. For your A2, we have 1 all over 2 times 2, because n will be 2. 2 times 2 is 4. Then this becomes 1 all over 4, which is 0.25. So we have 1 all over 4, right? For the third one, we have A3. We're looking for the third term in the sequence. We say 1 all over 2 times, this will be position 3. So you say 2 times 3. 2 times 3 is 6. So here you get your 1 all over 6 as your fraction. Am I right? Then for your position 4, okay. For your position 4, you say n will be in fourth position. So 2 times 4 will be 8. Your A4. So this will be 1 all over 8. 1 all over 8. Okay? Then for your position 5, this will be 1 all over 2 times 5. 2 times 5 for your fifth term. 2 times 5. So this will be 1 all over 2 times 5 is 10. This will be 1 all over 10. So if you look at your sequence, now if we write out your sequence, we have 1 all over 2, comma, and then we have 1 all over 4, comma, then we have 1 all over 6, comma, then we have 1 all over 8, comma, and then we have 1 all over 10. Okay? And then we have 1 all over 10. So these are first 5 terms in the sequence. These are first 5 terms in the sequence. So that's for the first question. That's for the first question. Okay? That's for the first question. And that's what you need to show. That's all you need to show for the first. Now we go to look at it here. 1 over 2, 1 over 4, 1 over 6, 1 over 8, and 1 over 10. So that's for the first one. The second question was, let's take a look at the question. The second question was to say, find the second and the third and the fourth terms in each of these sequence. Find the second and the, so you see A1, you say AN plus 1, this is a term to term. So to get the next one, you just have to say, so if A1 is 3, the first term will be what? Will be 3. First term will be 3. A2 will now be AN plus 1 will be 3 plus 6, which is 9. Okay, right? 3 plus 6. So let's write AN plus 1. This is a term to term rule formula for term to term rule. Now let's go to term rule. case, see, the next one will be 9. Term to term rule. So let's write the formula. What's the formula again? an plus y equals to an plus 6, where a1 is 3. Okay, for the first one, B Roman figure 1. Let's quickly handle that. B Roman figure 1. For B Roman figure 1, we have B Roman figure 1, we have an plus 1, an plus 1 is equal to an plus 6, right? And they define, for this question, they define a1 to be 3. They've defined a1 to be 3. So our first term in the sequence is 3. Remember that a1 is always the first term in the sequence. So a1 plus 1 now, which will be the second term, a1 plus 1. Remember, a1 is 3. a1 is 3. Now let's find a1 plus 1, which is a2. a1 plus 1 is a2, right? Because 1 plus 1 is 2. a2 will be 3 plus, from this formula, here is now, because a1 plus 1 is a2. a2 is now 3 plus 6. So you say 3 plus 6, which is what? 9, which is equal to 9. So this is your second term in the sequence. So our third term in the sequence will be a2 plus 1. You know you found a2 now. So the next one will be a2 plus 1. a2 plus 1, meaning the next term in the sequence will be what? Will now be this 9, because it's the a2 you got is what? 9. You now say 9 plus this 6. So you say 9 plus 6. 9 plus 6. So 9 plus 6 will give you 15. So that's what you got for this sequence, 15. Right? Then for your next sequence, which is a3 plus 1, a3, you know you've got a3 now. This one means a3. Or I can write it here. a3 is a2 plus 1. Okay? So your a4 will be equal to a3 plus 1. So a3 plus 1 will be what? What we got for a3? What we got plus a3, you add 6 to it. Remember from the formula, whatever you got in the previous term, you just add 6 to it. So you say, what we got in the previous term was 15. So you say 15 plus 6. And 50 plus 6 will be 21. Will be what? 21. Okay, A5, we do the last one for this term for this sequence. The last term for this sequence. A5 is A4 plus 1. A4 plus 1. Which gives you 21, because you got 21 for A4. 21 plus 6 from the formula. The 6 is coming from the formula. Because we're looking for term to term rule. The common difference is 6. Between one term and the next term is 6. So you add 6 to it to get the next term. You add 6 to it to get the next term, which is 27. So if you bring out your sequence out, the first term is what? If you bring out your sequence out, your first term is 3. Okay. Should we erase? It's not clear. Okay, your first term is 3. Your first term is 3. Sorry. Took erase, I thought of marker. Your first term is what? 3.
3.
Okay. Your second term is what? Your third term is what?
15.
Your fourth term is what?
21.
Your fifth term is what?
27.
Okay, so this is what they want us to generate the first 5 terms. We've done that. I think probably that's just what they want from us. Okay? You use to get the next term, you just use the term to term rule. To get the end term, you use the position to term rule. Okay, that's one thing that you have to take away from today's class. Okay, one thing you have to take away from today's class. Okay, so you do this yourself. You do this yourself, this and this. Try them. It's just to say whatever it is, the term, you say 3 times A what? A1 is 2. So A2 will be 2, whatever number is here, that is here, 2 square. 2 square, that's 4 times 3. 4 times 3, 12. 12 minus 1, 11. So the second term will be 11. Okay, because A1 is 2. So you put 2 here, 2 square, you get 4. 4 times 3, 12. 12 minus 1, you get 11 for your second term. Remember your first term is 2. The second one is 11. The third one now will be what you got just now, 11, right? 11 square, that's 121, times 3, then minus 1. You get the third term. That's how you do for this, and you also do for this. Is that okay? So I think if you want to see them briefly, if you want to see that briefly, I think they're here. Yeah, for that sequence, it's here. It's here. It's solved here. You just keep squaring, and you get this sequence. So that's all we have for today's sequence. If you look at this sequence, A4 is A3 plus A2. To get A4, you add A2, which is 6, and A3, which is 10. You get 16, right? And to get A3 is A2, A1 plus A2. That's 4. 4 plus 6, that gives you 10. So this type of sequence, where if you're looking for the third term, you have to add the first and second, is called the Fibonacci sequence. This one is called Fibonacci sequence. Where if I want the fourth one, I will add the second and the third. If I want the fifth, I will add the third and the fourth. So if I want the fifth now, I will say 10 plus 16, that's 26. The fifth sequence will be 26. If I want the sixth one, I will say 26 plus 16. So that type of sequence is called Fibonacci sequence. Okay? A4 will be A3 plus A2. A5 will be A4 plus A3. Is that okay? A6 will be A5 plus A4. That type of sequence is called Fibonacci sequence. Okay? So we've looked at type of sequence. Our next class we will now illustrate the types properly. The linear sequence, quadratic sequence. Example of quadratic sequence has 2 different cases. So next class we still starting from this type of sequence, okay? And we will give example as it were. Okay, thank you for joining us today.